Hey all, let's see the next topic. Continuation to Risc and Cisc. In this lecture, we are going to discuss about the example of a Risc and Cisc and Risc versus Cisc. In contents, we are going to see an example of Risc and Cisc architectures and the differences between Risc and Cisc. So, coming to the fundamentals of Risc and Cisc, as we have already discussed about the concept of Risc and Cisc in the previous lecture, let's just recap it. So Risc, as the name implies, reduced instruction set computer. It uses simple instructions that can be executed in a single clock cycle, and it implements the concept of pipelining technique. Whereas Cisc, the complex instruction set computer, it uses complex instructions which takes more than one clock cycle or multi-clock cycle to execute, and that performs several operations at a time. And if you see the design philosophies of Risc and Cisc, Risc prioritizes the speed and simplicity. It makes sure that the instructions are very simple and that can be executed in a less amount of time. Whereas Cisc, the main aim of a Cisc architecture is to minimize the size of your code and simplify the compiler design. Now let us look at a practical example of multiplying two numbers, how this particular example is applicable to both Cisc and Risc architectures. So if you consider a Risc approach, in case of a reduced instruction set computer, since it contains simple instructions, we are going to break down the task into simple steps and then execute them. So as I already told you, the Risc architecture is also called as load and store architecture. So implements the concept of load and store instructions and perform operations on the memory. So say for example, I want to multiply the contents of two memory locations. Two, three. This is a memory location where I have a first operand, and 5 2 is a memory location where I have a second operand. I want to perform a multiplication operation on these two operands. So, in case of a Risc approach, first the particular content operands has to be loaded into the particular registers, and then an operation has to be performed. As we know, Risc does not perform operations directly on the memory. So have to be loaded into the corresponding registers. So using a load operation, the first operand is loaded into the A register and second operand is loaded into the B register. Then we using product A comma B, we perform a multiplication and then store the result of A into the corresponding memory location. So each instruction perform exactly one operation here. And the instructions are simple instructions which can be executed in a single clock cycle in case of a Risc approach. Now coming to the Cisc approach, which is a complex instruction set computer, it uses complex instructions but powerful instructions which perform multiple tasks using a single command. So the same example, if I in case of a Cisc approach, they are applicable by using one complex instruction called mult. So if I give mult 2 is to 3 and 5 is to 2, it directly performs, as we know, the Cisc performs directly operations on the operands which are stored directly in the memory. So the one instruction loads the values from the memory location, it performs a multiplication operation and stores the result back to the memory location. All these steps are performed in one complex instruction in case of a Cisc approach. Now let us see the differences between Risc and Cisc, Risc versus Cisc. Now let us see the architectural differences. The key architectural differences. The first one is the instruction complexity. As we know, the Cisc uses complex instructions which take more number of clock cycles to execute, whereas the Risc employs simple instructions which takes a single clock cycle to execute. Coming to a memory access, Cisc allows many instructions to reference the memory directly, whereas in case of a Risc approach, it restricts the memory access only to load and store instructions. If you want to access the memory, that is only possible with the help of a load and store instructions in case of a Risc approach. Coming to a register usage, since you cannot perform operations directly on the memory, Risc uses more number of general purpose register for efficient operation. Whereas Cisc, it doesn't require registers, so it uses very few number of general purpose registers as the operations are directly performed on the operand stored in the memory locations. Next, coming to the execution model, the Cisc executes the instructions one at a time, whereas Risc it implements the concept of pipelining. So, at one point of time, more than one instruction can be present in the pipeline at a given state. So, Risc leverages the pipelining to process multiple instructions simultaneously. Let us see some more differences. With respect to the features such as instruction set, execution cycles, memory references, registers, pipelining technique, transistor usage, and number of instructions. So, in case of Cisc, the instruction set is very large and it contains a complex instructions. In the case of a Risc approach, the instruction set is very small and it contains simple instructions. Next, coming to execution cycle, Cisc instructions take multiple clock cycles to execute, whereas the Risc instructions, since they are simple, they require only one clock cycle per instruction. And coming to a memory references, many instructions can access the memory in case of a Cisc architecture. Only load and store instructions can access the memory in case of a Risc approach. And coming to the registers, in case of Cisc, we use very few general purpose registers, whereas in Risc, we use many general purpose registers. Next, pipelining technique is very difficult to implement in case of a Cisc approach, but in case of a Risc, it is easy to implement. Because in case of a Cisc approach, there exists a possibility of dependency between the instructions, which makes the pipeline difficult to implement. Next comes the transistor usage. In terms of the hardware, Cisc requires more number of transistors to implement the hardware, whereas the Risc it requires very few transistors. Next, coming to the number of instructions, Cisc approach minimizes the number of instructions per program and increases the number of cycles per instruction. In case of a Risc approach, it maximizes the number of instructions because you require more and more number of instructions to perform a given task, even though they are simple instructions. So it maximizes the number of instructions per program and reduces the number of cycles per instruction. Next, coming to the real world applications and examples of Risc and Cisc. If you look at the examples of Cisc, the Intel x86 and Pentium CPUs, they implements the concept of Cisc, AMD processors, VAX, the Motorola family, which are commonly used in our PCs, workstations, servers. All these processors, they implements the concept of Cisc. Coming to a Risc, this Apple-based chips, IBM Power, all the frequent which are the processors used in your mobile devices, real-time applications, your tablets, smartphones, all these applications, embedded systems, they all these implement the concept of Risc architecture. So this is all about Risc and Cisc. Thank you.